A study was conducted to determine whether magnets were effective in treating pain. The values represent measurements of pain using the visual analog scale. Assume that both samples are independent, simple random samples from populations having normal distributions. Use a 0.05 significance level to test the claim that those given a sham treatment have pain reductions that vary more than the pain reductions for those treated with magnets. So let sample 1 be the sham and sample 2 be the magnet. So variance 1 and variance 2. So the claim is that those given sham treatment have pain reductions that vary more than the pain reductions for those treated with magnets. This is expressed in a symbolic form as variance 1 is greater than variance 2. So it would be D. So we're going to let the alternate hypothesis be the one not containing the equality. So variance 1 greater than variance 2. And we're going to let the null hypothesis be the one containing equality. So to find the test statistic and p-value, since we're working with variation, we're going to use variance stats. And we're working with 2 samples with summary. We don't have the actual data. And from there, we're going to enter our variance. So variance for sample 1 is not given. We only have the standard deviation. So we're going to take the standard deviation and raise it to the 2 power, and it becomes variance. And the sample size is 20. For sample 2, we have the sample standard deviation. We'll take our sample standard deviation and raise it to the 2 power and becomes variance. And the sample size is also 20. So working with variances, so the null says that variance 1 is equal to variance 2. So that means if they're equal, their ratio is going to be 1. And if variance 1 is greater than variance 2, then that means the ratio is going to be greater than 1. Okay, we can also see the p-value plot. So here we have a 2 sample variance. This is our test statistic or F stats. And here's the p-value, the right tail test, where the right part of the graph is shaded. That's the p-value, and this is our test statistic. So the test statistic rounded to 2 decimal places going to be 1.80. And the p-value rounded to 3 decimal places, 0.105. So we're going to reject the null if p-value is less than significance level. We fail to reject the null if p-value is greater than significance level. Since our p-value is 0.105 and our significance level is 0.05, our p-value is greater than significance level, so we're not going to reject the null hypothesis. So we're going to go with the null. That means we don't have enough evidence to support the alternate hypothesis. So we fail to reject the null. There is insufficient evidence to support the claim that those given a sham treatment have pain reductions that vary more than those given